So today we're going to talk about L'Hopital's rule, but before that, let's review limits, because L'Hopital's rule tells us how to take limits of certain functions. So just to remind you, what is a limit? The idea of a limit is sort of like the best guess. You look at what's happening as you approach 3 from the left, you look at what's happening as you approach 3 from the right, and you look at this output, the height of the function, and if it's the same value from the left to right, then the limit exists and it is that value. So when we're doing this type of limit here with the formula, we know this is continuous, so we can just plug in 3, and if we get an answer, then that's our limit. So we have 3 squared minus 3 plus 5, and this is going to be 9 minus 3, which is 6, plus 5, which is 11. So that's nice and easy. But over here, something bad happens, and that's supposed to be a 3, so let's change that to a 3. As x goes to 3 on top, you get 3 squared minus 9, which is 0. And as x goes to 3 on the bottom, you also get 0. And so this is actually an indeterminate form. And when we have an indeterminate form, it just means we cannot determine the limit as given, so we have to do something else. And in this case, what we're going to do is we just factor the top. So we have the limit as x goes to 3 of x minus 3 on top times x plus 3, all divided by x minus 3. And here the x minus 3's cancel, and so this is equal to the limit as x goes to 3 of x plus 3, and then we plug in 3, so this equals 3 plus 3. Notice I dropped off the limit when I plugged in 3, so when I evaluate the limit, which means I plug in x equal 3, I can drop it off and I get back 6. A similar thing happens here. Notice when you plug in 1, you get 0 on top and 0 on the bottom, so you're going to get 0 divided by 0, which again is this indeterminate form, which means you cannot determine the limit as given. So you'd factor the top, factor the bottom, and again you get some cancellation, and then reevaluate the limit. So plug back 1 again and see if you get an answer. We're going to skip this one. We're going to come back to each of these later on using L'Hopital's rule to figure out the limit. But this one is a bit different. Now again, let's change colors here. You do plug in 0, and if you plug in 0, you're going to get cosine of 0 minus 1 divided by 0. Let's put parentheses around this. Not parentheses, but quotes, I mean. And then you get 1 minus 1 on top, which is 0 divided by 0. And so that's also an indeterminate form. So you need to do something else here. Now when we evaluated this limit, we figured out this limit, what we did is we plugged in points really close to 0. So I'd make a table here. Let's say x and then your function f of x. And I plug in a number like 0. Let's say 0.01. And so I take cosine of 0.01 and then take off 1, all divided by 0.01. And I can do this then with my calculator. So take out your calculator. And what we would do, clear that. All right, so I just take left parenthesis cosine of 0.01 minus 1 in parenthesis divided by 0.01 and see what I get out. And it looks like I get out a really small number close to 0. So that's a negative 1.523087. And then e to the negative 6 actually means move this decimal to the left 6 places. So this is going to be about 0. So my guess would be that this limit is actually equal to 0. And you'll see in the next section here in a little bit that we're going to, on the next slide, we're going to actually show that with L'Hopital's rule. We also had these limits as you go to infinity. Notice if you try to plug infinity, you're going to get infinity on top and infinity on the bottom. So this is another indeterminate form. But to do this one, the idea is because we're going to infinity, these terms really don't matter. So this is really equal to the limit as x goes to infinity. right? Compared to the square, infinity squared is so big that you can just cross off these terms. This is like, $1 billion compared to, $3 billion compared to 2 cents, plus 1. Right? It's nothing. So then you're left over with this 3x squared divided by 2x squared, and then the x squareds cancel, and so this is just equal to the limit as x goes to infinity of 3 over 2, which is equal to 3/2. This one, again, is a bit different. When you try to plug in infinity, you're going to get infinity times sine of 1 over infinity. Let's put that in quotes. Which is really infinity times sine of 0. 1 over infinity is like 0, and sine of 0 is 0. And this is another type of indeterminate form. And we'll talk about a few others in a little bit. And the idea is that it's indeterminate because this could be going to 0 the same rate as this is going to infinity, and somehow they could cancel, and you get out some sort of number back. To figure this one out, you might want to plug in a really big number. So we could do another table with x, f of x, and we could take, let's say, 1,000, and do 1,000 times sine of 1 over 1,000. And we could use our calculator, and we would see that 1,000 times, that's x, I meant times, the sine of 1 divided by 1,000, there's too many parentheses there, is equal to, and I get 0.17. I better make sure that I'm not up. Well, so there's a problem there because I'm in degrees, so that kind of messed everything up. So I should be in radians. So let's make sure your calculator's in radians. To check that, just hit mode, and then make sure radians down here is highlighted. I knew something was wrong because I got the wrong answer. So let's try this one again. So second, enter, and hit enter, and I get 0.999999 out, so it's approximately 1. So my guess for this thing, let's do it in blue, would be that this is equal to 1. And we'll use L'Hopital in a little bit to do it. Let's check, since I have to redo this, let's just hit second enter, and pull up that cosine one way back there. Hit some wrong buttons, so come on. Here we go. There it is. So let's just check this one real fast. So I get negative 0.004999. So if you got, that's what you should have gotten if you had it in radians. So again, it's still about equal to 0, and the answer is 0. All right, let's get away from this page and take a look at the next page here. And we want to talk about this L'Hopital's rule. So what is L'Hopital's rule? So the idea, it's given to you right down here, is that if you take a limit of f of x divided by g of x and get 0 over 0 or infinity over infinity, then to find this limit, all you need to do is take the limit as x goes to a of the derivative of f divided by the derivative of g. So it's the same thing. So let's take a look at these examples here. And let me close this. All right, so notice again, if you plug in 3, just like before, you're going to get 0 on top and 0 on bottom. And L'Hopital says that if you get 0 over 0 in this type of indeterminate form, you can L'Hopital it. Right? Some students like to say, take it to the La Hospital, right, to get fixed. So you take the limit as x goes to 3, and you can take the derivative of the top, which is just 1, divided by the derivative of the bottom, which is 2x, and you get this to be equal to 1 over 2 times 3, which is 1/6. Right, so if you check out the first problem we did up here, you should notice, oh, I wrote this backwards down here. So down here, I just wrote it, oh, it doesn't matter. You still get 1/6 out, so let's just keep it like that. That way I don't have to go back and change it. All right, now let's take a look at this one. What are we going to do here? If you plug in 1, hopefully you notice you get 1 minus 2 plus 1, which is 0. If you plug in 1 here, you get 1 minus 2 plus 1, which is also 0. So again, it's an indeterminate form. And so we can use L'Hopital. So this is going to be equal to the limit as x goes to 1. And we take the derivative of the top, which is 2x minus 2, divided by the derivative of the bottom, which is 3x squared minus 4x plus 1. And then we plug in 1 again. And when you plug in 1, you're going to see you get 0 on top. And then plug 1 into the bottom, and what are you going to get out? So 3 minus 4 plus 1, which is also 0. So you get 0 over 0, an indeterminate form again, which means you can just, if you want, L'Hopital it again. So we're going to L'Hopital this one twice. And so this is equal to the limit as x goes to 1. And then on top, I'm going to get a 2. And then on the bottom, I'm going to get a 6x minus 4. And then I'm going to plug in 1, so I'm going to get 2 divided by 6 minus 4, which is 2 divided by 2, which is 1. So that answer is 1. Over here, I'll plug in 0 again like I did before, but I'll get out, like last time, 0 over 0. And so I can L'Hopital it, so this is going to be the limit as x goes to 0. The derivative of cosine is minus sine of x minus 0, divided by the derivative of x is 1. And this is equal to then minus sine of 0, so I'll evaluate the limit, and that's just equal to 0. So that limit is 0. Whereas the limit for b was 1, and the limit for a is 1/6. And this is just using L'Hopital's rule, which just says if you have a limit and you get 0 over 0, this 0 over 0 indeterminate form out, you can take it, the derivative of the top divided by the derivative of the bottom, and take that limit, and you'll get the same answer you would have gotten here. Okay, let's look at one where we get infinity over infinity out. So notice if I plug in infinity here, I'm going to get 3 times infinity squared minus 2 times infinity plus infinity, which is just infinity on top. And you're also going to get 2 times infinity squared minus 5 here, which is also infinity on the bottom. And then L'Hopital says that I can simply set this equal to the limit as x goes to infinity of the derivative of the top, which is 6x minus 2, divided by the derivative of the bottom, which is 4x. Again, you get infinity over infinity when you plug in infinity. So I'm going to get infinity over infinity. I'll just put that in quotes because I'm just saying I get this indeterminate form, which then I can L'Hopital again. So this is the limit as x goes to infinity of 6 divided by 4. And you can plug in infinity. There's no place to plug it in, so you just get 3 halves. 6 over 4 reduces to 3 halves. Okay, so there are some other types of indeterminate forms, and so I wrote them below. So here are the 4 other indeterminate forms we're going to take a look at. So we have infinity times 0, we have 1 to the infinity, or infinity to the 0, or 0 to the 0. And now how are we going to solve these types? It's actually a pretty simple idea. You take a problem you don't know how to do and turn it into a problem that you do know how to do. So we'll try to turn it into one of these 2 forms, 0 over 0 or infinity over infinity. So let's take a look at the first example. And I'm going to need some more room here, so I'm going to come down here and copy these down. So the first example, A, we have the limit as x goes to infinity of x sine of 1 over x. Now when I plug in infinity, I get infinity times sine of 1 over infinity. I'm going to put this in quotes because this is equal to infinity times, now the sine of 1 over infinity is like the sine of 0, which is 0. So this is an indeterminate form because I don't know who's going to win out, infinity or the 0. And so the idea is I want to make this look like, if I can, let's say I want to make this look like, let's make this look like a 0 over 0 indeterminate form. And one way to do that, now think about this, is to write this infinity times 0 as 0 divided by 1 over infinity. All right, so you have this 0 divided by 1 over infinity. Now, you know, when you divide by a fraction, you multiply by a reciprocal, so this is still infinity times 0. So this is sort of the trick. So I'm going to rewrite this equal to the limit as x goes to infinity. Instead of writing x times sine of 1 over x, I'll write the sine of 1 over x, and then I'll divide this by 1 over x. Right? These are still the same thing. When you divide by a fraction, it's the same as multiplying by its reciprocal. So if you multiply by its reciprocal, you get this expression back right here. But now when you plug in infinity, you have sine of 1 over infinity on top divided by 1 over infinity on the bottom, which is like 0 over 0. And so I can L'Hopital it. So let's scooch down a little bit. And so this is equal to the limit as x goes to infinity of the derivative of sine is positive cosine, so cosine of 1 over x, times the derivative of the inside. Now the derivative of 1 over x is a minus 1 over x squared. If you don't know that, remember 1 over x is x to the minus 1, so its derivative is minus x to the minus 2. Right, the exponent comes down, and you take away 1. Then divided by the derivative of the bottom, well, it's the same as derivative right here, so you just get minus 1 over x squared. And then these are going to cancel. You have this on top, you have this on bottom, and so those cancel. And so this is equal to the limit as x goes to infinity of cosine of 1 over x. Let's plug in infinity, so I get cosine of 1 over infinity, which is equal to the cosine, 1 over infinity is like 0, of 0, which is equal to 1. So this limit right here is equal to 1. All right, let's take a look at the next one. So part B. And part B says the limit as x goes to infinity of 1 plus 1 over 2x to the 2x. If you plug in infinity, you're going to get 1 plus 1 over 2 times infinity, all raised to the 2 times infinity, which is really 1 plus 0, so that's just basically 1. Let's put quotes around this. Right, 1 to the infinity. 2 times infinity is like infinity. So this is another indeterminate form, and we're not sure exactly what's going to happen, if it's going to go to 1, if it's going to go off to infinity, or it's actually going to go to some number. And so to figure this out, what we can do is we can rewrite this expression using e's and ln's. So I can rewrite this expression using e's and ln's. And the way we do it is we use this idea of e to the ln of the anything is the anything. So this is the limit as x goes to infinity. And in the end, I want to write it as 0 over 0 or infinity over infinity. I want to write it in that form, then I can L'Hopital it. So watch what's going to happen here. So I'm e to the ln of the anything is the anything. So e to the ln of 1 plus 1 over 2x to the 2x. That's the same thing because 1 says e to the ln of the anything. It's just the anything. And then what I can do is I can move this 2x down in front. So this is equal to the limit as x goes to infinity of e to the 2x ln of 1 plus 1 over 2x. And then what do I have here? If you plug in infinity, hopefully you notice you're going to get infinity times ln of 1. So that's infinity times 0. So what I can do then is I can actually try to figure out what is this gonna be. So this is going to be the limit as x goes to infinity of e. And I want to figure out this limit. And what I have reduced it to is actually to the case in the top. Notice if you plug in infinity, so let me just show you this. If you plug in infinity for x, this is going to be infinity. All right, this is going to go to 0, so it's going to be ln of 1, which is ln of 1, which is 0. So you're going to get infinity times 0. So that's sort of like the indeterminate form up there. So we want to figure out, where is this thing going to, the question mark. And so what I can do is I can kind of do the question mark part on the side. So right here, let's write question mark is equal to, what is it equal to? It's equal to the limit as x goes to infinity. And that's just the top part. So what is this thing going to? What is the 2x ln of 1 plus 1 over 2x going to? And notice it's very similar to the one we did up here. All right, so what did we do up here? We rewrote it. If you you notice we rewrote it just like this. And so we can use the same idea down here. We can rewrite this as the limit as x goes to infinity of ln of 1 plus 1 over 2x divided by 1 over 2x. These are the same thing. When you divide by a fraction, you just multiply by the reciprocal and you'll get this back. But now if you plug in infinity, you're going to get what? You're going to get ln of 1 plus 1 over 2 times infinity, all divided by 1 over 2 times infinity. So let's put that in quotes, which is just equal to 0 divided by 0. So it's an indeterminate form. So then we can L'Hopital this thing. So now that I know I can L'Hopital it, this is going to be equal to the limit as x goes to infinity. Now the derivative ln is 1 over, so I have 1 over 1 plus 1 over 2x times the derivative of the inside. So the derivative of the insides, this is going to be what? This is going to be 0 plus the derivative of 1 over 2x. Now the derivative of 1 over 2x is minus 1 over 2x squared. And if you don't see that, remember the idea is 1/2 x to the minus 1. Its derivative, the minus comes down, so you get minus 1/2 x to the minus 2. And then all divided by, now this derivative 1 over 2x is here. It's the same as this thing right there. So the derivative of 1 divided by 2x is minus 1 over 2x squared. These will cancel, so let's change colors. This cancels with this on the bottom. And so this is just equal to, and this is me thinking over here, so let's put that in a little kind of thought circle there. And so this is equal to the limit as x goes to infinity of 1 over 1 plus 1 over 2x. And so I plug in infinity and I get 1 over 1 plus 1 over 2 times infinity. And so that's equal to 1 over 1 plus 0. And that's 0. And that's equal to 1. Now be careful, you're not quite done yet. What you just found out is that question mark here is equal to 1. So this answer here is equal to the limit, and I'm running out of room here, so maybe I can zoom out just a little bit. All right, so this answer right here, let's just draw an arrow. Let's go all the way down here, is equal to the limit as x goes to infinity of e to the 1, which is equal to e. And this is a tough one. This is one you're going to want to look at. We'll practice it again tomorrow. And let's finish this off. So there's one more left. So the last one we want to do, part C, let me switch to black, is the limit as x goes to infinity of x to the 1 over x. If you plug in infinity, you're going to get infinity to the 1 over infinity, which is the same as infinity to the 0. And again, you're not sure what's going to happen here. Is this going to blow up to infinity? Is it going to go to 1? Is it going to go to some number? And so we have to check this out. So let's see what's going to happen here. So the same sort of idea. Right, to change this into a 0 over 0 or infinity over infinity form. So remember the idea. We want to change it to 0 over 0 or infinity over infinity. Now, why do we want to change it into one of these two types of forms? So we can L'Hopital it. So what we do is we write this as e to the ln of x to the 1 over x. And then this exponent can come down in front. So this is equal to the limit as x goes to infinity of e to the 1 over x, ln of x. And so this is equal to then the limit of whatever this thing is. So let's just write e to the question mark. Right? So whatever that limit is as x goes to infinity, that's what that question mark is. So we just got to figure out question mark equals the limit as x goes to infinity of 1 over x, ln of x. And now if you plug in infinity here, you should see you're going to get 1 over infinity times ln of infinity, which is equal to 0 times infinity, which is a pretty nice indeterminate form because, again, we can turn this into, in this case, what we're going to do is we're going to turn this into infinity divided by infinity because we can rewrite this, if you notice. This is just ln of x, and this is just kind of silly, right? Divided by x. This is the same thing. Right? Remember, I mean, 2/3 is the same thing as 1/3 times 2. So the same idea is at work here. So 1 over x times ln of x is ln of x divided by x. And if you plug in infinity now, you're going to get infinity on top divided by infinity on bottom. So we can L'Hopital it. So this is equal to the limit as x goes to infinity. The derivative ln is 1 over x. And then divided by the derivative of x, which is 1. And then we plug in infinity, and you get 1 over infinity out. And that's actually equal to what? Well, that's actually, let me put quotes around that if you want. That's actually equal to 0. And so question mark's equal to 0. So up here, this is just equal to e to the 0. Right. Back here, if you noticed, I wrote the limit as x goes to infinity of e. I could, if I wanted to, I guess, if I want to try to make these very similar, I could just write right there what? I could just write e to the question mark. And so then I just found question mark was 1, so it's just e to the 1. So I could write it all in one line, I guess, if I did that. All right, so that finishes the lesson, and I'll see you guys tomorrow.